Good morning, guys. Welcome back. Moving through in our Math 30-1 trig unit. So we're in topic 4.3 in the textbook that we use, and which is called trigonometric ratios. So let's get into that one. All right. So idea behind trig ratios over here, we're looking at a general point xy. Okay. Now, if I draw a line out like this, kind of draw a triangle. Well, the bottom leg of the triangle is going to be the x-coordinate. The vertical leg of the triangle is going to be the y-coordinate. And then the hypotenuse, we're actually going to label r, because it's going to be the radius, in terms of the radius of the circle. So if we look at the first three ratios we're going to do are just coming from your old SOHCAHTOA ratios here. Okay, so what this means for again over here, so this is our angle theta in standard position over here. Well, sine theta is going to be opposite over hypotenuse, which in this case will be y over r. Cosine is going to be adjacent, or x over r. And then tan is going to be opposite over adjacent is y over x. Okay, so those are the we call the three primary trig ratios over here. So these are the three primary trig ratios. Now the next three are what we call the reciprocal ratios. So you guys are called reciprocals because they're the reciprocals of the three previous ones. So first of all, for this one, it says cusc, which really stands for cosecant. I'm just going to write this over here. So this is cosecant. And then the one below this, SEC, stands for secant. And then the last one, cotangent, is cotangent, like this. Now, what these ones are the reciprocals of the previous one. So cosecant is a reciprocal of sine. So if sine is y over r, this is going to be r over y. Secant is a reciprocal of cos, which is r over x. And cotangent is a reciprocal of tan, which is x over y. Okay? So these are going to be our three, we'll call reciprocal ratios over here. All right. Determine the exact values of each trig ratio, what this means over here. If we look at our unit circle over here, just going to draw a quick one. Okay, pi over 6 is this guy here. And really what we're doing here is like we've kind of made this into a triangle, right, where the coordinates are root 3 over 2, comma 1/2. That means that the y-coordinate is 1/2 from here to here, and from here to here is root 3 over 2. The radius on the unit circle is always going to be 1. Okay, so if we ask you for sine pi over 6, what we're doing is we're going the y over the r. Well, the thing on the unit circle is r is always 1. Okay, so the idea is on unit circle, any point xy is really equal to cos theta sine theta. Okay, same thing. So the x value would be adjacent over hypotenuse, or x over r, but if r is 1, that means our cosine ratio is just going to be the x coordinate over here. So we're asking for sine pi over 6. What this is asking us to do is, what is the y coordinate on unit circle at pi over 6? So looking at the unit circle we have on the right over here, so pi over 6, our y coordinates is 1/2 equals 1/2. Okay. Cosine 7 pi over 6. What this is looking for is x coordinate at 7 pi over 6. So 7 pi over 6 is down this guy over here, so there's our 7 pi over 6, and the x-coordinate is going to be negative root 3 over 2. 10 5 pi over 3. Okay, so 5 pi over 3 is this guy here. Now we said before, what's tan equal to? Tan is y over x. Okay, so looking over here, my y coordinate is root 3 over 2, my x is 1/2. So this is going to be negative root 3 over 2 divided by 1/2. Okay, now just a bit of fraction rules over here. Negative root 3 over 2 divided by 1/2 is the same thing as negative root 3 over 2 times 2 over 1. So it's like multiply by the reciprocal. These 2's cancel out like this, and our answer is negative square root of 3, like that. All right, cosine 240 degrees. Same idea as the last ones, except now we're in degrees. But so we're going to find 240 degrees. It's going to be 240 in degrees is right here. We want the x value for cosine, negative 1/2. All right, we've got a few more of these examples to go through. Tan power 3 of 3 pi over 4. So first of all, what this means, this cube's kind of written in a strange spot, but this is kind of a convention that we do in our trig unit, how we write these guys. So this really means the same thing as tan of 3 pi over 4 cubed. Okay, so all we're going to do, find 3 pi over 4 here. Tan is y divided by x. Okay, so it's going to be we have root 2 over 2 over negative root 2 over 2, and we cube that. Now, these numbers are the same, but one's positive, one's negative, so this is going to be the same thing as negative 1 cubed, which is negative 1. Okay, sine squared of 5 pi over 3. So 5 pi over 3 is this guy over here. Sine is our y coordinate here. So this is going to be the same thing as negative root 3 over 2 squared. The negative becomes a positive. Root 3 squared is 3. 2 squared is 4. Next one, we have sine pi over 6. Sine pi over 6 is 1/2. It's the y coordinate at 1/2. Plus cos squared of 5 pi over 4. 5 pi over 4 is this guy over here. Cosine is the x coordinates, so it's going to be negative root 2 over 2 plus negative root 2 over 2 squared. So we have 1/2 plus, the negative is going to cancel out because we're squaring it. Root 2 squared is 2 over 4. So this is really 1/2 plus 1/2, which is 1. All right, h, secant of 5 pi over 6. Okay, now remember secant is a reciprocal of cos 5 pi over 6. So what I'm going to do, we're not going to do this every time, but so if we find 5 pi over 6 here, cosine is negative root 3 over 2. So I'm just going to write down cosine of 5 pi over 6 equals negative root 3 over 2. Therefore, secant of 5 pi over 6 equals negative 2 over root 3. Now what we should do here is we should rationalize our denominator. You're going to find that the standards are kind of a bit looser in terms of rationalizing your denominator in this course over here. You'll see answers sometimes like in the back of textbooks and stuff like that, or even on tests sometimes where you have an irrational denominator. But we're going to do everything properly here. So I'm going to multiply times root 3 over root 3, which gives us negative 2 root 3 over 3. And this is our answer for secant 5 pi over 6. So for example I, so this is, cosecant is the reciprocal of sine 7 pi over 6. Okay, so sine 7 pi over 6 is the y coordinate here. Okay, so I'm just going to flip this guy right away. So I know it's the reciprocal of this guy over here. So this is going to equal negative 2 over 1 squared, which is just positive 4. We have cotangent of 4 pi over 3, and cotangent is the reciprocal of tan, or it's x over y. Okay, all right. So 4 pi over 3 is this guy right here. Okay, if I go x over y, it's going to be this divided by this. Okay, the x coordinate divided by the y coordinate. So we get negative 1/2 over negative root 3 over 2. And we're going to square this. Okay, so it's dividing two fractions here. So this is going to make negative 1/2 times, I'm going to flip the bottom fraction, 2 over root 3, and that's negative, squared. Those guys cancel out. This is negative 1 over root 3 squared equals positive 1/3. Okay, so this is going to be our answer for this guy over here. Okay, next example. The point negative 12, 5 is the terminal arm of angle theta in static position. List the 6 trig ratios and the value of angle theta to the nearest hundredth of a radian. All right, so what we're going to do here is I'm just going to draw, well, where's negative 12, 5? It's going to be 12 to the left and 5 up. So it's going to be, let's say, over here somewhere. Doesn't need to be perfect for this diagram, but just graph it like this. Okay, now the terminal arm, if you remember, goes from, here's our initial arm, and here's our terminal arm like this. So we're saying that this point lies on the terminal arm over here. That means our angle theta is this guy over here. Okay. Now, what we need to do is we're going to draw a triangle like this. Okay. So based on this triangle, we have negative 12 as our x, 5 is going to be our y. The way we're going to figure out our radius is just with Pythagoras theorem. So we have 5 squared plus negative 12 squared equals 25 plus 144, which is 169, and the square root of 169 equals 13, which is this guy here. Okay, so we're asking for the 6 trig ratios. That's ratios, not rations. Typo there. So we need to figure out what is sine theta, cos theta, tan theta, cosecant theta, secant theta, and cotangent theta. So sine is y over r. Cosine is negative 12 over 13. This is going to be x over y. Tan is going to be negative 5 over 12 because we're going y over x. Okay. Now once I have these ones, the 3 reciprocal ones are really simple. We're just going to go and flip the previous 3 above it. Okay. So cosecant is a reciprocal of sine, 13 over 5. Secant is a reciprocal of cos, negative 13 over 12. Cotangent is a reciprocal of tan, so it's going to be negative 12 over 5. Okay. Last part, they want angle theta to the nearest hundredth of a radian. Okay. Now what I'm going to recommend is you use this one over here. What I mean by use this one over here, like for the primary 3 trig ratios, we have a positive one and we have 2 negative ones over here. I think it's going to be a lot easier if you choose to use the positive one over here. So this is going to be a bit of a review back to math 10 and math 20. In math 30, we actually learned what an inverse does. And we kind of always referred to like sine inverse in math 10 and 20 without really explaining what an inverse did. But what an inverse does is it flips your input and your output values here, right? So if I go sine inverse of 5 over 13, I'm just going to go grab my calculator here. So in this one, we want to make sure the calculator is in radian mode because they're asking us for the nearest hundredth of a radian. I can go second sine of 5 pi, which is 5 over 13. And that gives us I'm going to round in a second here, because we're not quite done. Now, this answer of 0.39 is not this angle. So this is our angle theta, but it's actually giving us this one over here, which we call the reference angle. So we talk about reference angles in Math 20 a bit. We'll talk about it a bit more in a second here too. But what this is going to be here, so that's talking about this angle here, which is 0.39 ... So the way to figure out angle theta, well, if you see like this is like 180 degrees minus this part, but we're in radians, so I'm not going to use 180. This angle theta is going to equal pi, because that's 180 degrees in radians, minus 0.39479 ... So on my calculator, I'm just going to go pi minus that answer, and we get hundredth of a radian, 2.75. So that's going to be our angle for this. It's going to be 2.75 radians from there to there. Okay, so we talked about reference angle in the previous slide. A reference angle is the acute angle formed where the x-axis is the terminal arm of angle theta in standard position. I'm just going to kind of make another example over here. So we do 145 degrees. Well, here's 0, here's 90, here's 180. 145 will be somewhere like this. Okay, that means this angle is what we call our reference angle. So the way we're going to figure out this one, well, is this guy is a full 180 minus 145 is going to give us this reference angle. So theta reference angle equals 180 minus 145 equals 35 degrees. That means this guy over here is 35 degrees. If I did do a couple more here, if I have 212 degrees, this would be down here. Because like this is 180, so I'm going slightly past like this. So this is 212. Well, my reference angle in this case is going to be 212, the whole thing, minus 180 in this case. So we want to be able to eliminate the top part and just have this reference angle here. So theta r would be 212 minus 180, which is 32 degrees. One more here. Let's do the same thing if theta equals, say, 305 degrees. So this will be 270 here, this will be 360 here. We're going to be down in this region over here. So there's theta. The reference angle would be this guy over here. So this one is going to be a full circle minus the 305 degrees. So we're going to go theta reference is 360 minus 305 equals 55 degrees. Okay, this is kind of how we figure out reference angles. Point 10, -4. So this is the exact same question that we had before. List the 6 trig ratios and the value of angle theta to the nearest hundredth of a radian. Okay, so we're going to go 10, -4 will be down here. Okay, so my radius is going to be 10 squared plus -4 squared is 100 plus 16 is 116. Square root of 116 is 4 times 29. So I'm just going to reduce this radical here. Square root of 4 is 2. Okay, so this is the reduced version of the square root of 116. So that means we have a value of 2 root 29 here. Okay, so I'm going to do my primary trig ratios first. Sine theta, cos theta, and tan theta. Sine theta is going to be -4 over 2 root 29. We're going y over r. And I'm going to rationalize this denominator times root 29 over root 29 equals negative 2 root 29 over 29. So there's your answer for sine theta. Cosine theta is the same thing, except it's going to be x over r. Simplify this. Okay, so there's our cosine theta. Tan is going to be y over x. And we get this. All right, for the reciprocal ratios, we're just going to take the reciprocals of these guys. So we have cosecant, secant, and cotangent. Now, what I'm going to do, rather than flipping the simplified version, I'm going to flip this version over here. It's going to be much easier because then now I just got a root 29 on top over this, and I'm already rationalized. Same thing over here for the secant. I had 5 over 29, so I'm going to make this guy root 29 over 5. And cotangent is going to be negative 5 over 2. Okay, so there's my three reciprocal trig ratios as well. Okay, example 5. Determine the value of sine theta given that secant is 29 over 29. 29 over 21. So remember her secant is r over x. This is what this one worked over here. So with our over here, now we're telling that quadrant the angle theta is in quadrant 4. So what I'm going to do is I'm just going to draw, this is not going to be to scale by any means, but I'm just going to draw a triangle in quadrant 4 like this. Where our value is 29, and that means our x value is 21. Okay. Now what the question is asking us for is sine theta. Now sine theta is y over r. Okay? So we need to figure out what's this y value here. We're going to use Pythagorean theorem for this one. So we have 21 squared plus y squared equals 29 squared. That means y squared equals 29 squared minus 21 squared. And then we're going to square root this. And we get an answer of 20. Okay. Now, in this case, it should be plus or minus 20 normally, but in this case, since y is going to be in the negative direction going down, we're actually below the x-axis over here. This is going to be a value of negative 20, like this. So, therefore, sine theta is y over r is negative 20 over 29. All right, guys, I'm going to stop this video here and just going to take a bit of a break, and I'm going to continue this lesson off in a moment here.